right, so again, Chapter 8, Part 1. What I've done with Chapter 8 is, in Chapter 8, you have two different parts, really and truly. You have the algebra part, and then you have the graphing part. So what I've done is, in Part 1, we're going to do all the algebra aspects, and then in Part 2, we're going to take the algebra that we're learning in Part 1 and apply it to graphs. In 112, how many of you like to graph? 2 people. Yay. In 112, we will do a lot of graphing. A lot of graphing. Don't let that scare you, because what's my goal? Everyone's going to pass. Hopefully. That's my goal. So we will do a lot of graphing, and that's another reason why I want you to print out the PowerPoints, because with the PowerPoints, you'll already have the graphs, and you don't have to worry about doing the graphs. All right. So the first thing we're going to talk about is we're going to go from our Math 100 algebra, which is where you just work with basic equations and you learn how to play around with those equations to find the things that you need. And we're actually going to take those equations and we're going to turn them into a function. A function is nothing more than a workable equation to where we can get what we need. We're going to put things in, and then you're going to get stuff out. So it's an actual machine. So a function, y equals f of x. And the reason I say that is because in basic algebra, if you saw something that said y equals 2x plus 3, tell me everything that you know about y equals 2x plus 3. It's a linear equation. Slope is 2 over 1. Intercepts y-axis at positive 3. So the fact that it's a linear equation, what is it going to graph? A straight line. Okay? So this is basic slope-intercept form. And this is what you're used to seeing. Right? If I asked you to solve for x, you could do that, right? You can manipulate this equation and solve for x, yes? But what we're going to do is we're going to take this equation and we're going to turn it into a function. So don't let this notation throw you off. Literally, all we're going to do is replace that y with f of x. Or if it was something like, and we can use any variable that we want to, it doesn't really matter. F of z is going to be 2z plus 3. Okay, any variable that you want to do. Reason being is because when you throw this into a function, if I'm interested in an ordered pair at z or x is equal to 5. Well, if I make x 5 for an ordered pair, what else do you need? An ordered pair consists of x and y. So if I tell you that x is 5, could you find y? What would you do? Yeah, you're going to plug 5 in for x and solve. And so y is going to be what? 13. Okay? And so that's what we're doing. We're turning our basic linear equations, or in this class we're going to do quadratics and higher degree. So we're turning them into a machine. Okay, so some vocabulary. Domain. Anytime you see or hear me say domain, we're talking about the x values of the ordered pair. The x values of the ordered pair, or ordered pairs. Basically, for our functions, your domain is going to be any x value that you can plug in and make the function real, make the function true. So, for example, if I have a fraction up here and I say 2 over 3x, and I say f of 0, can x be 0? Because watch what happens. And it's undefined. Okay? So x would not be a part of your domain for that function. Do you see what I'm saying? Your domain is what your x values can be, not what they cannot be. Your domain is what your x values can be. All right? So the other one is your range. Your range is your y values. Your range is what numbers am I going to get out if I plug all these x's in. Okay? Now, if you have a linear equation, or if you have an equation that does not have a fraction and does not have a radical, your domain is any number you want it to be, from negative infinity to positive infinity. Okay? But if you have a fraction, you have to make sure your denominator is not going to be 0, like what I just did. Alright? So, if on your first test, I gave you a set of ordered pairs, such as this. If I gave you a set of ordered pairs, and I asked you to tell me the domain, easiest 5 points you've ever made in your life, right? If I gave you a set of ordered pairs and I said, tell me the domain for this set, you would tell me all of the x values. Right? And then if I asked you, well, what is the range? You would tell me what? All of the y values. Easiest points in the world. But you're going to forget it for some reason or another, and you'll miss that. It's the easiest question on your very first test. If I give you a set of ordered pairs and I ask you, tell me the domain, you would not believe some of the answers that I've got. Don't make that mistake, okay? So, your domain is just your x values, and your range is going to be your y values. Okay, the other question that I'm going to ask you is this set of ordered pairs, or I can even give you a graph, and I can say, is this graph, is this function actually a function? And your answer is either yes or no. Okay, you got a 50-50 shot. Look, right here. It says the following set of ordered pairs is a function because none of the x values repeat themselves. Does it matter about the y values? Don't care about the y values. The y values can repeat themselves. The x values, however, cannot repeat themselves. So the fact that none of my domain, none of my x values are the same, that tells me this is a function. None of your x values can repeat themselves. Because remember, it's a machine. It's a machine. If you plug 2 into the machine, you get 5 out. Okay? Well, if I turn around and I plug another 2 in, what am I going to get out? Another 5. That's ridiculous. That's redundant. Okay? So your x values cannot repeat themselves. Your y values can, but your x values cannot. So, 3 questions already we've talked about. Can you tell me the domain if I give you a set of ordered pairs? And can you tell me the range? And can you tell me if the set of ordered pairs is a function or not? Okay. 3 questions. The next question on your test is going to be this. I'm going to give you a graph, and I'm going to say, is this graph an actual function? Is this graph an actual function? And what you're going to do is you're going to use the vertical line test. Vertical line test. Why, Miss Adams, are we using a vertical line? Why not a horizontal line? Well, let's think about it. In order for a function to be a function, what cannot repeat? The x values. X values cannot repeat. So if I draw a vertical line, let's say right here. If I draw a vertical line right there, let's look at some of the ordered pairs, okay? This ordered pair is -7, 4. This ordered pair is -7, 2. This ordered pair is -7, 0. This ordered pair is -7, -2. This ordered pair is -7, -4. Is this vertical line a function?
No, because the domain's the same in every one.
Exactly. This vertical line, a vertical line can never be a function. The reason being is because every time you draw a vertical line, all of the x values are exactly the same. And I've already told you that in order for it to be a function, none of your x values can repeat themselves, right? So, what happens if I drop a vertical line through here?
Not a
Exactly. If I drop a vertical line through here, I have 3 ordered pairs that would have the exact same x values. So this is not a function. Not a function. Because you have a vertical line that has 3 ordered pairs that are going to be the exact same. What about this one? Yes or no?
No.
No. You have 2 x values that are going to be the same. What about this one? No, because you're going to have 2 x values that are going to be exactly the same. Well, what if we go to the ones on the top? If I drop a line here, is it a function? Yes. It only touches one time. And honestly, I can drop a vertical line anywhere I want to, and it's still going to touch only one time, which means none of the x values repeat themselves. None of the x values repeat themselves. Here, same thing. This ordered pair may have an x value of 3, 5. Yet this ordered pair would be -3. And we're just pretending. -3, 5. Do you see that? The x values are not going to repeat. This one could be 0, not 2, 0, let's say 8. Okay? So if you can drop a vertical line and it only touches one time, then your answer is yes, it's a function. But if you drop and it touches more than one time, then the answer's no. Okay? So, 4 questions. What do you think? Can you get them? All right. All right. So, how are we going to use this domain and range? How are we going to use what we just learned and actually apply it? Well, if given the domain, what are you given? The x, okay. If given the domain, you can find the range, what are you going to be finding? The y, and it's an ordered pair, okay? For every x value, you have a corresponding y value if you have a function. If you don't have a function, then the y is going to be undefined. That's the whole point. Connect those dots. If given the domain, you can find the range by substitution. This is called finding the functional values. So this is what I'm going to ask you to do. I'm going to give you a function. This particular function is f of x is equal to x squared plus x minus 3. Okay? That's your function. Can anybody tell me if I graph this what it would be? I hear it. It's a parabola. The fact that you have one squared term, that's a parabola. If you don't have any exponents at all, that's a straight line. Do I expect you to know that? No. If you do know that, you're ahead of the game. That's good. We're going to learn that in this class, though. All right. So if I gave you a quadratic function such as this, and I wanted to find some specific ordered pairs, okay, this is called pre-cal. So in calculus, what we're going to do is we're going to maybe test a stress on a machine. And I want to know what's going to happen to this machine if we plug in 2 volts or 2 whatevers. What's going to happen to the machine? So that's how this would apply to calculus. And that's what we're doing. So if I plug in a -2 for this x, I want to know what am I going to get out? You do the math. You do the algebra. So, for example, if I want to know what f of -2 is, watch this. I replace this x with a -2. So what do you think I'm going to do with this x? Replace it with a -2. What do you think I'm going to do with this x? Replace it with a -2. So now what I have is -2 squared plus a -2 minus 3. Do you know what to do from here? All right, you're doing order of operations. That's all you're doing. You're doing order of operations. Calculator. Totally would suggest that you get those calculators. Definitely need to use a calculator. If you don't have a calculator, make sure you know order of operations. Okay, so you're going to do those exponents first, and like you said, -2 squared is going to be 4. And then from there, you're just using the left to right rule. 4 minus 2 is going to be a 2, minus 3 is going to be a -1. What have you just found? Connect the dots. What did you just find? The range. You just found the y value. So could you make an ordered pair? What's the x value? What's the y value? Okay. So let's try f of 2. So now we're going to have 2 squared plus 2 minus 3. What do you think? So 2 squared is going to be 4, plus 2 is going to be 6, minus 3 is going to be a 3. So you have an ordered pair of 2, 3. Well, f of a, you'll understand this in calculus. We're going to use this in calculus to find basically the slope of a tangent line. All right? But it's the exact same concept. Instead of having a concrete number, now we're thinking abstractly. And that's what algebra is. Algebra is thinking abstractly, outside the box. Okay? But it's the same concept because watch. I replace this x with an a. So what do you think I'm going to do with this x? It's going to be an a. And what do you think about this x? It's going to be an a. Now watch what happens. So now my function is going to turn into a squared plus a minus 3. Can you do any algebra to that? Can you do any math to that? In other words, can you find the range? If I plug in a, do you know what the range is going to be? I know some of you are thinking, well, can we factor it and solve for a? Well, the factors of negative 3 are going to be 1 and negative 3 and 3 and negative 1. And that's not going to give us 1. So this one isn't a factor. So if I gave this problem to you and I said, okay, guys, what's the domain? What would you tell me? What's the domain for this problem? A. What is the range? Your range would be a squared plus a minus 3. That would be your range. A squared plus a minus 3. Because the range of this function is totally contingent on what would make a. Same thing as x. The exact same thing as x. Okay, so let's do this. F of 3a. So now we're going to have 3a as our base for our squared term. Make sure you write this correctly so you know what's going on, okay? X is your base of your squared term. Well, we're replacing x with 3a. That's a product, okay? So now your base is going to be 3a. So be careful when you write that. So we're going to have 3a quantity squared plus 3a minus 3. This time we can do some algebra, right? 3a squared is going to be what? 9a squared. And then you can't do anything else. So your range for this one is going to be your domain is going to be 3a, and your range is going to be 9a squared plus 3a minus 3. Pure substitution. Okay? So let's talk about a piecewise function. How many of you have ever seen a piecewise function? Yay, that's good. All right, a piecewise function means this. You have two different functions, two different graphs on the exact same coordinate plane. So instead of just graphing the parabola or just graphing the straight line, now what you're going to do is you're going to graph, well, if we were doing chapter 8, part 2, you would be graphing. But what you're going to do, what you have here, and you need to go ahead and get a visualization so that when we get into part 2, you're going to understand what's going on, right? Right. What's going to happen is now we have two graphs on the exact same coordinate plane. So this is a straight line, f of x equals 2x plus 1, and this is a totally different straight line, and I'm confident that every one of you can graph these two lines, right? Slow If you intercept form, y equals mx plus b, rise over run. Okay. But a piecewise function means that what's happening is it's telling you in the problem which x values go with which graph. So for example, if your domain is any number greater than or equal to 0, you're going to use this top graph. You're going to use this top function. If your x value is less than 0, you're going to use this bottom function, this bottom graph. Okay? So look at what I've done. I've given you specific domains, specific x values that I'm interested in. I'm only interested in what happens to this machine if I plug a 2 in, what happens to this machine if I plug a 4 in, what happens to this machine if I plug a -1 and a -3 in. That's what I want to know. Well, if I want to plug a 2 in, but I have 2 different valves that I can plug this 2 into, and if I plug it into one, the machine's going to explode, and that's not what we want. But if I plug it into the other one, I'm going to get a good function out. I'm going to get a good range out. Alright? So let's figure out which valve I'm going to plug this 2 in. Look at this. This valve, you can only plug numbers that are equal to or greater than 0 into it. Whereas this valve, you can only plug in numbers less than 0 into it. Okay? So, which function am I going to plug this 2 in, top or bottom? Top. Which function am I going to plug the 4 in, top or bottom? Top. Which function am I going to plug the -1 into, top or bottom? Bottom. And which function would I plug the -3 into? Okay, trick question. Which function would I plug 0 into, top or bottom? Top. Why? Because of this little line right here. Because of this little line. X can be equal to here, but X cannot be equal to here. So don't let that throw you off. If I gave you a 0, make sure you look for that little line. Alright, so let's do this. If I have f of 2, f of 2 goes into the top one because it's greater than 0, so we're going to have 2 times 2 plus 1. And we're going to get what? F of 4. Again, that's going to go into the top because 4 is greater than 0, so we're going to have 2 times 4 plus 1, which is going to be what? And if I do f of -1, -1 is less than 0, so we'll plug it into the bottom. And we're going to get what? And if I plug in f of -3, again, that's less than 0, so it's going to go into the bottom. And what are we going to get? -10. Pure algebra. We haven't done anything too difficult, right? Alright. So let's try this one. See if we can figure this one out. Now this one's kind of tricky. And I'm going to show you why before I let you try on your own, because I don't want you to be stumped. This is what I want you to do. I want you to, first of all, figure out which function we're going to plug into. Okay? So, f of 3. Top, middle, or bottom? So our top one we have x is less than 0. Our one in the middle we have any number between 0 and 4. And our bottom one we have anything above 4. So 3 falls in between 0 and 4, so we are going to use the middle. So we're going to have 3 squared plus 1, which is going to be 10. Did you see how I figured that out? You have to know your domains. You have to look at these domains to figure out which one we're going to use. If my x value is 3, this one says x less than 0. 3 is not less than 0, so we throw that one out. This one says any number between 0 and 4, including. Why do I know it's including 0 and 4? Because the line underneath there you can be equal to, and that's where the 3 falls into play. Okay, f of 6. I agree with the function, yes. We're going to plug 6 in here. So 6 is greater than 4, so we are going to use this function. 6 is greater than 4, so we are going to use this function. But my y value is -1. a horizontal line. This is a horizontal line. Because what's going on is this. No matter what number I plug in as an x, I'm going to get 1 out. I don't have a choice. There is no variable. No matter what number I plug in for x, I'm going to get a negative 1 out. So if I plug in 6, I'm going to get 1 out. If I plug in 3, I'm going to get 1 out. If I plug in 0, I'm going to get 1 out. If I plug in 8, I'm going to get 1 out. If I plug in negative 3, I'm going to get 1 out. It's a horizontal line. Okay?
Because there's no process to it, it's just a number by itself.
Watch this. You have the function f of x is equal to negative 1. Let me write it the way that you're used to. Y equals negative 1. If I ask you to graph y equals negative 1, what would you do? You draw a horizontal line going through the y-axis, or through the y-axis. That's a horizontal line. The exact same thing. This is what you're used to seeing, and this is what we're working with now. Okay. So, what if I said f of 0? F of 0, which function, top, middle, or bottom? Yeah.
And then include 0 and 4.
That's right. So your range is going to be 1. F of negative 3, top, middle, or bottom? It's going to be top, less than. What's your range going to be?
2.
2. That's another horizontal line. No matter what I plug in that fits in this description, of course, I'm going to get a 2 out. So it's a horizontal line crossing the y-axis, I think. Okay? So don't let that throw you off. So, what are we going to do? Again, this is pre-cal algebra. Pre-cal algebra. So, and again, remember our little deal at the beginning. If you need a break, take a break. Just understand I'm not stopping. But you're more than welcome to get up and do whatever. Again, pre-cal algebra. So we are building blocks using we already have our building blocks from algebra, right? We should have our building blocks from algebra. If not, we're going to make some. And so now in this class, what we're going to do is we're going to have building blocks for calculus. And that's what you're going to do. How many of you are going to take calculus? Ooh, that's exciting. I'm teaching calculus next semester. So if you like this class, but you got to have trig first. How many of you had trig in high school? How many of you have trig in high school? So y'all can go straight from here. Anyway, so what we're doing is we're doing building blocks for calculus. This is called the difference quotient. This is called the difference quotient. The difference quotient is a function, or it's a tool, I guess you could say. And in calculus, we're going to use the difference quotient to find the slope of the tangent line to any curve. Okay? So you need to know how to do the difference quotient before you get into calculus, because if you don't learn how to do it now and you get into calculus, you're going to be like, oh my gosh. Okay? So for the difference quotient, what we're going to do is exactly like what we've been doing here. We're going to use substitution and figure out what the difference quotient is. Now, little hint, let's see if we can make a connection here. If I told you that the function was f of x is equal to 2x plus 3, there's your function. Okay? There's your function. And I just told you that the difference quotient is used to find the slope of a tangent line. Could you tell me the answer if I applied the difference quotient to this problem right here? What's the answer? Take a guess. If I apply the difference quotient to this function, and the difference quotient tells me the slope of the function, could you tell me the answer without even applying the difference quotient? It's going to be what? 2. It's 2. Right here's your slope. This is y equals mx plus b. Slope intercept from 1, y equals mx plus b. Your answer is 2. So if you have a linear, if, and this would be awesome on your test, this would be a bonus question right there. If I gave you a linear equation, I said apply the difference quotient to this function. And tell me the answer. One more time. If I gave you a linear equation in slope-intercept form, mind you, if I gave you a linear equation in slope-intercept form and I asked you to apply the difference quotient to this function as a bonus question, would you get it right? The question is, could you get it right in 2 seconds or could you get it right in 2 minutes? Because that's the difference. If you miss this connection that I'm trying to get you to understand right now, if you miss the connection, what you're going to do is you're going to, I'm going to get this bonus question because I know how to do the difference quotient. You're going to take the difference quotient and you're going to apply it to the function and you're going to take 2 minutes doing a whole lot of algebra to come up with 2. Or you can know the slope of the linear equation. The difference of 2 minutes versus 2 seconds. Okay? But, huge side note. It has to be a linear equation in order for you to do that. If it's a higher order equation, in other words, if it's anything higher than a linear equation, you have to apply the difference quotient. Have to. So if it's a second degree equation, do you understand what I'm saying when I say second degree equation? It has to have an exponent of 2 in it. If it's a third degree equation, fourth degree equation, you have to apply the difference quotient. But if it's a linear equation, it's telling you the slope. That's all you have to do. It's telling you the slope. Okay. So, if this is your function, and I ask you to find the difference quotient or apply the difference quotient to this function, do you actually have to apply the difference quotient or can you look at it and tell me the answer? You have to apply it. Why? It's a second degree equation. So you actually have to apply the difference quotient. Now, this is what I'm going to do. I'm a very systematic person, so I have steps. So if you want to follow the steps and put it all together to come up with your answer, that's fine. Some of you geniuses don't have to follow the steps. You just plug it in and go with it. That's fine too. I don't care how you do it, okay? I am not the math Nazi. You do not have to do everything my way. I teach it the way that I feel like it's going to get across the best way. But if it's too confusing for you and you can do it the other way better, go for it. I'll show you both ways. Okay? So, let's use the steps. So, to find the difference quotient, let's talk about this. Your difference quotient is this. F of A plus H minus F of A all divided by H. What in the world does that mean? Well, that means you have 1, 2, 3, 4 things to do in order to find the difference quotient. Okay? You have to find your function if I plug in A plus H. You have to find your function if I plug in A. Then you have to subtract the 2 polynomials. And then you have to divide by H. A lot of algebra. A whole lot of algebra. Let's try it. So, step number 1, let's find F of A plus H. In order to find F of A plus H, everywhere, look, here's the problem, okay? This is just the formula that you're using. This is the problem. Formula, problem, okay? If I take this X and I replace this X with A plus H, we've been doing this for an hour now, right? If I take this X and I replace it with A plus H, can you tell me what I would write? And I'm glad somebody said that. Now, you can pull it. Okay, I'm going to get on a little soapbox here. If you had me from Math 100, you know what I'm about to say. A plus H quantity squared, simplified, is not A squared plus H squared. Don't do it. Don't do it. Because, what is the meaning of X squared? So what is the meaning of a plus h squared?
2a plus 2a.
And anytime you multiply two binomials together, what method do you use? The full method. Okay? So, or how many of you know the pattern? Square, double, square? Do you remember the pattern square, double, square? You can do that too. If you don't want to do the whole entire full method, you can do square, double, square. We're going to do the difference quotient enough between this class and those of you going on to calculus to where you're going to know a plus h quantity squared is automatic. Okay. But if you don't know it, pull it out. Do that for me right now. Do a plus h quantity squared simplified. Do a plus h times a plus h or use the pattern. It's your choice. So you should come out with a squared plus 2ah plus h squared. Square, double square. Where does that come from? Well, you have a plus h times a plus h. Pull it out. First times first is a squared. Outer 2 is going to be a times h. Inner 2 is going to be a times h again. And last 2 is going to be h squared. Combine the middle 2 and you have a squared plus 2ah plus h squared. Square, double square. Okay? So, now, I want you to simplify this, and that's what we just did. This is as simplified as it can go. I can't combine any of this stuff. None of these are like terms, so it has to stay this way. Okay? So that, watch this. This, a squared plus 2ah plus h squared minus 3 is just this. We've only done one portion of this. Okay? So let's do the second part. It's a little bit easier. We're doing f of a. What is it going to be? F of a is going to be what? A squared minus 3. Okay? So that's this portion. Now, step number 3 is we're going to subtract the 2. Now, if you remember from algebra, when you subtract polynomials, you have to be very careful. You have to make sure they're in the correct order. Okay? So f of a plus h has got to come first. So we're going to have a squared plus 2ah plus h squared minus 3 minus a squared minus 3. Okay? So what I did is I did f of a plus h minus f of a. Step number 1 minus step number 2. Okay, a little hint for you. How do I know that I'm on the right track? Well, everything in f of a should cancel out with something in f of a plus h. That's how you know you're on the right track. So watch this. A squared minus a squared. What happens? They cancel out. Negative 3 minus a negative 3. Yeah, because negative 3 minus a negative is the plus. Y'all remember that? Negative 3 minus a negative 3 goes to 0. And so what are we left with? We're left with 2ah plus h squared. And then the last step, divide by h. Okay. So, remember from algebra again. This is another indicator to know that you did this right. When you get to this step, in order to cancel your h's out, there has to be an h in every single term. If there's not an h in every single term, you can't divide. Okay? There has to be an h in every single term in order for you to divide. There he is. So what's going to happen is we're going to cancel out one and only one h, and we're left with 2a plus h. And that's the difference quotient. Okay? You try.